Hello, everyone. Welcome to the second session of Beyond Bohm, Science, Order and Creativity, Physics and Metaphysics. I'm James Barbieri, Associate Program Director here at the Parr Center, and I will be your host for today. So as a host, any problems, technical or not, just drop me a message in the chat and I'll try to help you out. Before we begin, I'd just like to remind everyone of a couple of Zoom rules. It's a good refresher for those who are regulars and good to know for the new ones. First of all, we ask participants to turn off their microphone during the presentation and Q&A just to ensure a good quality audio. For this reason, we may mute you if we hear any background noise, but don't worry, this is not to silence anyone and you will have the opportunity to speak during Q&A. But at the same time, we do encourage you all to turn on your camera as we believe seeing everyone's faces and reactions creates a nice, inclusive education environment. During Q&A and discussion, if you want to ask a question or make a contribution, you can use the raise your hand function on Zoom, should be at the bottom of your screen under reactions. Otherwise, you can write your question in the chat. Otherwise, you can raise your hand. It's a bit more difficult for me to spot, but I may be able to see you. I'll call you out and you can ask your question. Finally, this session is recorded for archival purposes and for you all. The recording should be available 3 days after the recording. If you don't receive it, please email us and we'll try to send you the link to the recording. Okay, well, with that, let's begin with this session. Today we have the honor of introducing Professor Giuseppe Vitiello. Giuseppe is Professor of Physics at the University of Salerno in Italy. He is an associate of the National Institute of Nuclear Physics, the INFN. His research focuses on elementary particles, condensed matter physics, biological systems, and brain studies. And he's also published over 250 papers and books, including the book, My Double Unveiled, the Dissipative Quantum Model of the Brain. Today, Giuseppe will talk about the brain and its mindful double. And with that, I'll pass it over to you, Giuseppe. A very warm welcome.
Thank you to everybody, and I'm very happy to be here. And I really hope that next time, anytime at Paris, there will be one more meeting. It will be in presence, as we now say when we can shake our hands. At the moment, we only share our electromagnetic image, which is, by the way, what we usually do. Because even when we are in presence, what we share is art, jumping photons between us. So the idea here is to connect a little bit with David Bohm. Let me share the screen. I hope you can see.
Yes,
yes, James? It's okay. So the idea is to connect a little bit with David Bohm ideas, but starting from the point of view of a quantum field theory. Here I would like to stress this point. It's not just quantum mechanics. In some sense, quantum field theory was born with the Dirac equation in 1928. And then a new story started. This new story is, in some sense, quite different from quantum mechanics. I used to say that quantum field theory is like a book. You have a book, and if it is an interesting book, let's say a book of novels, in every page there is a novel, a different novel in every page. So each page is a quantum mechanics, namely that novel. Then you might move, turning the page, to another novel, and you will have a phase transition to different novel. You might even have the same actors, persons. The people could be even the same, but the story is different. So you said this by just saying that in quantum field theory, you have infinitely many unitarily inequivalent representations of the canonical commutation relations, which is quite, I mean, you must be of the to understand these things. But this means simply that in quantum field theory, you might study phase transitions. The equations are the same, but the manifestation of these equations are different because different are the boundary conditions. So let me start with the first slide where I give, let me see how. Okay. You see, this is the this is a sketch of the every kind of experiment can be reduced to such kind of sketch, because you have an input, you send inside to a region which is the interaction region, something A and B, think of particles, or also think of photons. You want to watch something, you send, you put light on something, and so the region where there is interaction is not accessible. Is not accessible in a quantum theory, even in quantum mechanics, because otherwise you observe not what you wanted to observe, but the object observed by you. So you interfere with the object. This might change completely the story. So in order to study the interaction between the objects in input, you do not have access to this dynamical region. Think, for example, of an accelerator or just any scattering process. You send a neutron on a crystal and you see the scattering neutron phonon. What you observe is the output of that scattering. So your detectors in input and in the output, they are very far in principle, and this is in principle, please notice, extremely far in such a way that you could say that in the place where you put your detectors, there is no more interaction you suppose there is in the interaction region. This is in principle because, for example, if you have electrodynamics, then potential goes like 1 over r, and this goes to 0 at r infinity distance. But is a good approximation if you are far away from the interaction region. You see, in this way, we are assuming this is metaphysics. This is outside physics. This is assumption made to justify our life as a physicist. We assume that we can distinguish a proton. Suppose you have a proton and an electron, and you want to study the scattering electron-proton. So we do assume that there are asymptotic fields, where asymptotic means far in time and space from the interacting regions. And similarly, you assume that there are the output of your experiment, and these also exist as individual objects, namely such that you can say that out of this interaction, for example, it came out an hydrogen atom, or electron and proton just not changed by the interaction, or anything else you could imagine. So this is the general setting we have in our mind. Quantum field theory is a two-level language theory. There is the dynamical level to one of the interaction region, and for that level, you write a Lagrangian. So the Lagrangian we write is a Lagrangian controlling, out of which you can get the Hamiltonian, of course. It works your field equations derived in the usual way through Euler equations. They are written for the interaction field, also called Heisenberg fields, this psi of x and t. And then you have the field equation for psi fields. And these equations, which are the dynamical equations, they might have symmetry group. Namely, they might be invariant under transformations of the psi field under some group of G of transformations. This is very important because this is very helpful if you find the symmetry group under which your field equations are invariant. You might get more easily the equations. The reason for that is that the dynamical equations usually are nonlinear equations, so they are difficult to be solved. They are nonlinear equations in the psi field. Then you have at the phenomenological level. Phenomenological means what appears, finite, in Greek root, nothing complicated, what we do observe. You see, we do not observe the psi field. We assume that exists something which we can call field, such that you can write a Lagrangian and what I said before. So you have a phenomenological field. This field describes things which you do observe in your lab. So I should write phi in or and phi out, because these phi are the fields you do observe in the asymptotic regions. You call this also physical field, because this is physics. Physics is the possibility to observe something out as an output of an experiment where you are doing, you planned to do something and you are sending an input. And for this phi field, you have a field equations. Now, these field equations, they are linear in the phi field. They are practically a projector on the energy momentum space for the phi field. They tell you that if you are in a relativistic regime, E square is equal to P square plus M square. And for such a situation, for the phi fields, you might write, you might just specify the physical state space, which I call HF, where F stands for Fock, because Fock space is the usual name you give to such a space. So these are the states to which we have access. We do not have access to states for the Heisenberg fields, because they are not observable. The only states we have access in our observations are states made by physical fields. And this state also have a symmetry group. Now, it happens that this symmetry group may not be the same as the symmetry group of the dynamical equation. So let me call it C instead of G. So G and C, they might be different. I will give you an example of such an occurrence. So to solve the equations, you must operate with psi fields, which these fields are operator field, of course. These are mathematical objects, very well defined, and they are operator fields on some space. So psi cannot operate, we do not know how psi operates on the Heisenberg states, because we do not observe Heisenberg states. We only observe physical states. So we have to map the operation of psi through a dynamical mapping. You see, there is another psi, this is a capital psi. This is a functional, a nonlinear functional of the asymptotic fields. Of course, you might have many asymptotic fields, not just one. Here, for simplicity, for notational simplicity, I will write just phi, but you might have phi 1, phi 2, phi 3, I mean, as many as you want. As many as you want means an irreducible irreducible set of physical states, in terms of which you can write anything else in your theory. So we pretend to be able to write such a dynamical mapping between the asymptotic fields and the Heisenberg fields. And these symbols means that we compute these, since these are operators, we compute these over states of HF. So by doing this, we have an highly nonlinear operation. And our physics is known when we find such a relation. So such a relation is a relation between C numbers, because these are vacuum expectation value. You see, we do not know how psi operates on HF, but through the dynamical mapping, we can know that. In this equality, it happens that what I said already before, namely that the invariance of the dynamical equation under the symmetry group G manifests. This is a weak relation, a relation between numbers, not any more operators, because these are sandwich. So G symmetry manifests in the C symmetry. And so we have a dynamical rearrangement of a symmetry. G goes to C. Now, let me stop for a moment here. You see, let me make an example. Suppose psi field, they describe an atomic gas. So you have an atomic gas at a given temperature. You have the field equations for such a gas of components. And this gas is invariant under continuous translational transformations, because any atom can be everywhere it likes. But if the boundary conditions are appropriate, you might get out of this a bunch of atoms, which is a gas of atoms, you might get a crystal. A crystal, the atoms are the same, but the crystal is a new novel. It's not the same novel as a gas. The crystal is a novel where the dynamical symmetry group, the continuous translational invariance, is now the crystal group, is a periodic discrete symmetry group. So you see, a truth dynamical mapping, you have, let me use the word by David Bohm, you have a unfolding of the order of the crystal. This crystal order C is in some sense folded in the symmetry group G. Let me give you another example. You might have a psi, this is a spin field. You have something, anything with a spin, like electron. So you might have electron gas. Electron gas with spin, you have a spherical rotational symmetry. And this rotational symmetry is SU2 symmetry, a special unitary group symmetry you might adopt for your Lagrange equation. You might write Lagrangian in such a way the symmetry group is SU2. But once you turn the possibility to evolve for such spin gas, you might get a ferromagnet. And in a ferromagnet, you do not have any more SU2 symmetry. You have a U1 symmetry around the magnetization, and you have two translational condensation symmetry. So you have the E2 group. You can show this in full details, formal details. So in this case, the E2 symmetry, which is an ordering, the order of a ferromagnet, you have a magnetization which was not here at the dynamical level. So this order is now appears at a phenomenological level, but at a dynamical level, you will not observe this ordering of a magnet. You will just have the spin gas, but that spin gas was including the dynamical possibility to show at the phenomenological level as magnetization, as a ferromagnet. So you have a dynamical rearrangement of symmetry. So at the end of the story, quantum field theory, you might think of a dynamical level, which is the linguistic of the Lagrangian Heisenberg fields. And then this level might split in many levels. You might have a crystal, magnets, depending on the system you have, you might have many representations. As a matter of fact, the Stone von Neumann theorem in quantum mechanics tells you that all the representations of the canonical commutation relation or anti-canonical anti-commutation, canonical anti-commutation relations if you have fermions. So all the representations are unitary equivalent. This theorem holds for a finite number of degrees of freedom. So in quantum mechanics. But in quantum field theory, there is no more such an hypothesis. If you take the von Neumann book on Fundaments on Quantum Mechanics, immediately you see that that hypothesis is crucial to show the theorem. Once you lose in the finite number of degrees of freedom, a field by its same definition is infinitely many degrees of freedom, then the von Neumann theorem does not apply anymore. And you might have the richness of infinitely many unitarily inequivalent representation. Unitarily inequivalent means that there is no unitary transformation relating one representation to another one. It is a different system. A magnet is a different system physically. I mean, there are observables like magnetization, which are not in the case in which the magnet is reduced to a gas of spins. The same for the crystal and so on. So at the dynamical level, you have a symmetry, the original dynamical symmetry, which might dynamically rearrange. And here I like to talk of metamorphosis. This is the place where a form appears. So you have a metamorphosis depending on where you, or which of these should be infinitely many lines, of course, as I said, where you are landing at the phenomenological level. And you have a metamorphosis, so dynamical rearrangement of the symmetry. And this symmetry, at this level, you can observe ordered pattern, magnet, crystal, elementary particles, hadrons, where quarks interact, and you cannot observe quarks, of course. So I like to stretch the point, just to borrow from David Bohm. You have at this level, at the dynamical level, an implicate order, which unfolds on the way of the dynamical rearrangement of symmetry into an order. So this is the way morphogenetic works. You have a metamorphosis, the appearance of forms. Now, I have been talking of quantum field theory, but James announced my talk as a talk on the brain. So I should go to the brain at this point. But for the brain, we find something which is, I mean, all of this is extremely useful, because we may have a quantum model for the brain, which was originally formulated by Hiromi Umezawa, one of the father of modern quantum field theory. And in Naples in 1967, he was proposing, together with Luigi Maria Ricciardi, to study the brain as condensed matter. Namely, he proposed to use quantum field theory to study the many particle system made by a brain, because you might think of neurons, glia cells, dendrites, and all that as a many body system. So what happens if you apply such a two-level language of quantum field theory in the study of the brain? Now, oh yes, here is our David Bohm. I took this from these infinite potential movie pictures. Okay. So for the brain, let's stay with this picture here because it's nice. Now, for the brain, we have to consider one aspect, which is, I mean, as a physicist, I cannot just forget about this question. The brain is always open, is an open system, is open on the environment. Of course, you could put the question of the existing world and everything, just forget about it. Just be a flat physicist. The world is there, you can observe it. You must be very careful if it is a quantum system, but if you look at the moon just does not care about you, stays there beautifully as she is. It is, I should say. But in any case, the brain is an open system. Open means that it exchanges with the environment, energy, matter, information. There are fluxes of exchange, continuous, even when we sleep. A dead brain is a closed system. Now, yesterday there was mentioned the fact that now in physics, in classical physics, Newton physics, let's say, and in closed system physics, we do not have now. Why it is so? Because of a Noether theorem. A Noether theorem tells you that if the system is invariant under time translational continuous symmetry, so if we could move the origin of the time on the time axis, then the theory implies that there must be a conserved quantity. This quantity is the energy. If there is a continuous translational space symmetry, then there must be a conserved quantity. This quantity is quantum momentum. If there is rotational continuous, then there is conservation of angular momentum. So every conservation has a corresponding invariance in the theory. This is Noether theorem. This is Noether theorem. Now, just focus on the energy. If there is invariance under time translation continuous, please notice, continuous time translational symmetry, which means we can move the origin of the axis as we like, then energy is conserved. But what means energy is conserved? The system is closed. So this cannot apply to the brain, because by its nature, the brain is open. It is a fact. You cannot deny that. Close a brain, close somebody, an animal or a person in a closed room, and it will be the end for that subject. As we know, as we experiment, I mean, in psychology, psychiatry, I mean, the prison is a physical punishment, really physical, because the brain is open system, and when you close somebody, cut links with the environment, you are forcing, you are doing some corporeal punishment on that person. So the brain is an open system. Energy is not conserved because it's exchanged. We need to eat. In a while, we will have a dinner. It is a part of that energy goes to our brain, and so on. So the brain is a dissipative system. Here I use the word dissipative with bad accent. I apologize for English-speaking people, but in any case, dissipation here means both ways, not only giving up. You are dissipating the money of the family. This is very bad. No, not only that. You might even collect money from outside. So I'm using dissipative to mean that a system is an open system. The brain is a dissipative system, is connected with the environment. Now, it happens that in the early 40s, Carl Lashley, who has been a master in modern neuroscience, he introduced the concept of mass action in the so-called Lashley dilemma. Let me read you, these are Lashley words. Here is the dilemma. Nerve impulses are transmitted from cell to cell through definite intercellular connections. Okay, you can observe, they do observe in neuroscience laboratory these things. Yet, all behavior seems to be determined by masses of excitations. Within general fields, notice he is using the word fields, within general fields of activity, without regard to a particular nerve cells. What sort of nervous organization might be capable of responding to a pattern of excitation without a limited specialized path of conduction? The problem is almost universal in the activity of the nervous system. This is beautiful because this is a really anti-atomist or anti-atomistic approach. You need to know every little piece of the matter you are studying in all possible details. But then you must ask which are the collective modes by which the functional activity of that piece of matter is working. You see, this is the point. This is Lashley dilemma. How to go from the neuron, the nervous cell, which is connected, is correct, is connected to another cell, but it's not that connection responsible of the brain functioning. Of course, neuroscience is always oscillating between the two extremes, either too much functionalism, think of a behavioral approach and so on, or too much atomism, and this is biomolecular neuroscience. But they must be integrated. They will not be successful if they go by themselves. The knowledge of neurons in all the possible details, is absolutely necessary. But what Lashley is telling us is that it is not sufficient if you want to study the brain. If you want to study the neuron, then that's fine. You are free to study the neuron, study dendrites, synapses, glia cells, whatever you like. But you are not yet studying brain. That is a different problem. Carl Pribram, who has been connected with Lashley even as a scholar, when the laser physics came out, and in the laser physics you study a system of photons in phase. So you do not study each photon, but you study a bunch of in-phase photons. Then he was thinking of a Lashley dilemma. He was proposing the hologram picture to study the brain. Because you see, there is a big problem still unsolved by biomolecular, the most modern you can imagine research in neuroscience. Where is memory in the brain? Of course, synapses are modified. Of course, neurons, they fire yes or not, and so on. But where is the memory? Where is what you remember at some point? In which part of the brain? So Pribram was proposing the brain as a hologram. An hologram is a picture, as any other picture, but has the property that in each corner, if you know the phase of the laser which has created the hologram, then you can reconstruct the whole picture. So you see, this is a collective mode, as we understand it in physics. And Pribram was trying to extend such an idea, such a picture, such a dynamical picture, please notice, to the brain study. You can find, of course, these are the reference and everything is here. So the macroscopic activity of a neocortex, I should rush a little bit because I spend too much time on quantum field theory. Namely, okay, so the mesoscopic activity of a neocortex consists in the dynamical formation of spatially extended domains of amplitude modulated AM, synchronized oscillations with near zero phase dispersion. So you have an orchestra of neurons playing music, a coherent orchestra. This amplitude modulated, and also there are phase modulated. Walter Freeman, who has been related to both of them, Pribram and Lashley, called the packets of waves, but these packets are not the physicist packets of waves toward the air, but he was using packets of waves. They form in a few milliseconds. This is the time scale for the brain. Have a property of location. They are localizable. They last for 80 to 100 milliseconds. They have carrier frequencies in the beta gamma range between, namely, meaning between 12 and 8 hertz. They form in such, as I said, in such time scale, and they disappear. And then they resynchronize in frame at the rate of 3 to 12 with a frequency between 3 and 12 hertz, very low frequencies, you see. Hertz, through a sequence of repeated collective phase transitions. So the brain is a system where you have always many, let's say, is a system continuously undergoing phase transition. This is the brain state. It's far from the equilibrium, does not stay in one phase. We are used to consider matter as living in one phase. A superconductor lives in at the temperature where it lives is a superconductor. But then if you tune the temperature, if you warm up, it loses the property of being a superconductor. The same with magnets, the same with crystals. They live for quite a long time in their phases, but they have many phases. And you need quantum field theory because each phase is a representation. Quantum mechanics is not enough to study a crystal melting or a magnet losing magnetization and so on. The brain is continuously undergoing, it's the life of the brain, it's continuously undergoing phase transitions. And this happens in quite large regions, in small animals, usually used in neuroscience lab, rabbits, cats, or in humans. The typical size is 20 centimeters, which is the size of our school. These are the orchestras playing. This picture like this, nowadays, you see many of them because in the functional magnetic resonance imaging, you can produce this. This, of course, is one instantaneous, is one photogram in a movie. These blobs or orchestra of synchronous oscillating neurons, they change, as we said before, and you have a different rearrangement. And you see, this is a very interesting point. Every time, well, at the brain, there is a map of the brain, which is extremely well known. We know exactly which one is the region active if you look at an image or if you listen at a sound. But all these specialized regions, they are always the starter for the involvement of the whole brain. This is why, for example, it's possible a recovery of some functional activity. Even if there is a specialized region in the brain for a given activity, and is known which one is that region, neuroscientists say no. Nevertheless, the whole brain enters into action. So the brain is really a collective mode system. How is it called? This writing, the caption of this picture is very interesting. The images reveal the highly organized nature of intrinsic brain activity. Intrinsic brain activity, highly organized. And they are represented by correlated spontaneous fluctuations in the functional magnetic resonance signal. Correlations are depicted by arbitrary color scale and so on and so on. So we are talking of an ordered structure. We have ordered patterns. Remember, we were talking of dynamic or rearrangement of symmetry. So we are facing a continuous unfolding of ordering. At each moment in our brain, at each moment means the scale is milliseconds, we have different orderings in our brain, which are formed and changed and reformed in a different way. This is Walter Freeman. Unfortunately, he left us in 2016, and he was a genial person. I was so lucky to meet him, and when we met, I was thinking of this model taken starting from Umezawa, of course, and he is a neuroscientist. But he has been, I mean, his fingerprints is on neuroscience of this of today, of modern neuroscience, and so he's a big boss. I mean, but when I met him, it was the person I needed. So I said, well, you will be my experimentalist because I'm a theoretical physicist. I need a lab, I need experimentalists. You are my experiment. Of course, he smiled to me because nobody was talking, dare to talk to him in such a way. He was a big boss. I mean, it's, you see, Neapolitan can do that. So he has been my experimentalist. Okay. I miss him really. Now let's see something about this dissipative quantum model of a brain. It is the extension to dissipation of the dynamics of the many body model formulated in 1967 by Ricciardi and Umezawa. Ricciardi, he was writing, in any material in condensed matter physics, any particular information is carried by certain ordered pattern maintained by certain long-range correlation mediated by massless quanta. He was talking here of a crystal, of magnets, of quarks. It looked to me that this is the only way to memorize some information. Memory, he was talking of a natural brain here, memory is a printed pattern of order supported by long-range correlation. Which one is the meaning of these words? Long-range correlations. Well, let me anticipate one part of the story. In physics, we know how to create the long-range correlation in a crystal, which is the responsible of the crystal. This is the phonon. How phonons, which are the quanta of the elastic waves, who is telling to a given atom in a crystal to stay at its own place, to do not move around, is the phonon. The phonon is the quantum of the elastic wave. Out of which the phonon comes? The phonon comes because of the Nambu-Goldstone theorem. The Nambu-Goldstone theorem in quantum field theory tells you that if you have a symmetry in the dynamical level of the theory, now you know what is the dynamical level, in your Lagrangian, in your Hamiltonian, if you have a symmetry there and you break that symmetry, which means that the states, the physical states, do not possess the symmetry of the field equations. I gave you the example of the crystal. The crystal has a periodic discrete symmetry. That is a state of the system. But the original theory, the original Lagrangian, is invariant under continuous translational, space translational symmetry. So the translation, the continuous translational spatial symmetry is broken in the crystal states. The SU2 symmetry is broken in the ferromagnet, where you can only orientate around the axis of the magnetization without expense of energy. So you have a spontaneous breakdown of symmetry. How the system appearing to us, crystal, magnets, hadrons, how the order is created? Is created because the Goldstone theorem says that when you break the symmetry, then dynamically long-range correlations appear. Long-range correlations are the phonon. The phonon spans the system and keeps the atoms in their crystalline sites, in the lattice sites. The spin wave spans the magnet and is responsible of the spin ordering. In such a way, you get the magnetization. So, which one is the symmetry in the brain to create these long-range correlations? Long-range correlations which are responsible, according to this model, of memory printing. But please notice, memory printing is a collective model. We are not saying that memory is in the neuron, like Haeckel's grandmother neuron. You remember, Haeckel was proposing once, then he said, okay, I was wrong. That the memory of his grandmother, there was a neuron somewhere in his brain remembering his grandmother. But if that neuron will die, as neuron dies, they die and they are regenerated, the grandmother will die, or at least memory of the grand. And so he said, okay, that was a stupid story. Memory is not localized in cells. Memory is a collective mode. Where is the crystal? The crystal is the phonon. Please notice, the phonon is a real particle. You can have scattering. You shut neutron on a crystal, which means you do scattering phonon neutron, and you do observe what happens in the crystal, namely the change of the phonon structures. But the phonon exists only when the crystal exists. There are no phonons coming outside the crystal. They are confined in the crystal. There is no memory coming out of our brain. Memory is a collective mode confined to our brain. Is a dynamical collective mode, please notice. It's not something which is there. Which you can take out. The existence, writes Umezawa and Ricciardi, of almost simultaneous response in several regions of the brain, a kind of a long-range correlation, does not find any explanation in terms of activity of the single nerve cells. New non-classical mechanisms have to be looked for. It then arises naturally a possibility. It is strongly suggestive of a quantum model. So you have a quantum model for the brain. Of course, these things, they cannot be understood by people far away from the conceptual framework and the formal also, I should say, because without mathematics, many things cannot be really understood. So you find a lot of people, they just say, no, it's not possible. I do not see anything classical, quantum. We met, Walter Freeman and myself, we met at a conference in near Munich, and I gave to him my book, My Double Unveiled, and I told him about the quantum model. He was a very kind person. He said he listened, then Then he put his my book in his wallet. This, and then he added, "I do not see anything quantum in my lab," and that was the end of the story. But 1 year after, he came to Rome for a conference, and he wrote to me if he could stop to Salerno, just for half a day. So what, not a touristic stop as we used to do also in physics. It was because he brought to me a few pages and he said, "I think we can write a paper together." We did write that paper. Is on Physics of Life review, and it was 2006, but we started 2003. And he was so taken by this idea of generating long-range correlations in the brain. He said to me that perhaps we were on the way to, not to solve, but to better understand Lashley dilemma, which, please notice, in today, what is today, 11th July 2021, is still there. Neuroscience has not solved the Lashley dilemma. They do not know how you memorize any of the stupid things I'm telling to you. So this is Umezawa. Umezawa is, of course, a samurai. He has been my teacher. I did a PhD with him. He moved from Naples, and he was a scandal in Japan because he was awarded by to the theoretical physics chair in the Yukawa place, Yukawa Nobel Prize. You know, Japanese are very kind people, very respectful, and but he left. He left, creating a big problem to who left there. And because he said that he needed a place where to work in physics, to do his physics in a free way, without constraint. And then after wandering around, he landed to Naples. He stayed 3 years there, where he wrote that paper I've been mentioning to you about brain, and other papers, of course, in quantum field theory. Then he moved to the States, first to Wisconsin and then to Edmonton in Canada. How to say? My words, the words I'm just pulling out, no, how to say, pushing out, words I'm putting out, are not my words, are words by Umezawa and by Walter Freeman. I'm so grateful to them because the only thing, those small things I know I learned from them. Okay, so this is a summary. Spontaneous breakdown of symmetry at the dynamical level of quantum field theory. You have a long-range correlation due to Nambu-Goldstone model, and you have ordered patterns because long-range correlations. Please notice correlations, not interactions. I will specify this difference. And then you have order as lack of symmetry. This is the opposite of what in everyday life we think of. We think of order like symmetry. No, you get order when you can distinguish things. Symmetry is when you cannot distinguish things, as the word, the etymology, symmetros. As you do a transformation in a system, the system appears to be the same. The equation do not change. That is symmetry, and that is not order. Order is when you obtain something, you can make a distinction. You can distinguish. So if you want the start of the story, of the human story, is Babel, the Tower of Babel. When language, they became different. That was the start of the story. That was not the end, but it was the real start. But that is another discussion. Okay. I already gave you, so I can jump on this example of Nambu-Goldstone modes, energy at Nambu-Goldstone, are phonons, magnons, spin wave, Cooper pairs in superconductors, and so on. Now, what happens? Where is the symmetry for the brain? It happens that the water matrix in the brain is more than 80% in mass. Water molecule is very light with respect to other biomolecules. So in number, the water molecules, they are above the 90%. Now, even if you are not a physicist, can you study what does the biomolecule for getting the 93, 94% of the other objects in which the biomolecule is embedded? I mean, would not be a wise thing to do. So you must consider what happens in the water bath. If you do that, you immediately realize that water molecule is an electrical dipole, which is vibrating at any small change in the electromagnetic potential, or even just electric perturbance. So these are the quantum variable, the electrical dipole vibrational field of the water molecules and of other biomolecules, because all the biomolecules you consider and you know, all of them, they have an electrical dipole. This is why every student, even at the first year of a biology course, he knows that he cannot separate completely from water a protein when he is producing a protein in his lab. Because if you take out all the water, you risk to break the protein chain. So water comes always with biomolecules. And you have electrical dipole. And this electrical dipole, in principle, they can point in any direction. So you have a spherical symmetry, like you have with spins. That is magnetic momentum. Here you have an electrical momentum. So you have a spherical symmetry in your Lagrangian. But that symmetry is broken. It's broken by the input coming from outside to the brain. This was the model by Umezawa and also in my extension. The input from outside breaks such a symmetry. Then the Goldstone theorem tells you that long-range correlations are created through these quantum variables. You have long-range correlations among the water electrical dipoles. This creates a non-permanent, this is very important, a non-permanent but it is ordered states when it is there. The fact that it is not permanent is crucial because we said already that the brain is in continuously undergoing phase transition. So if the ordering would be one of a crystal, namely the electrical dipoles of water molecule would freeze there, then we would not be able to think, or I mean, the functionality of our brain would not be what we know it is. We would be crystals, but we are not crystals. So it's beautiful the fact that let me say in this way, that water does not have a memory in order for us to collect memory, to record memories. Because memory is a collective mode, as we have already said. So through spontaneous breakdown of symmetry, we have such a, this ordering in the water facilitates the neuron activity. And this is the field that Lashley was mentioning in his dilemma. Neurons are connected physically by dendrites, synapses, but are not those responsible of the functional activity of the brain. Are not neurotransmitters that relate neurons among themselves. They are too slow. Freeman was computing the speed of chemicals in the brain, and he said these are not neurotransmitters. They are neurotransmitters, but they need a railroad. The railroad is made by the long-range correlation of the water bath in which neurons are embedded. Since you have such a railroad, I might come by train from Salerno to Siena, and then by car to Paris, because there are streets. But without railroads, my train would never reach Siena. The train is like neurotransmitters. The railroad is the dynamics underlying the brain activity. So I hope now, please notice, there are other quantum model, quantum in quotation, for example, Einstein, Ameroff, Stuart Ameroff, Penrose, but other ones too. In those models, usually cells are considered to be quantum objects. This is not true. It cannot be. I mean, Freeman was extremely right. He does not observe anything quantum at the level of molecular biology. He observes classical interacting chemical objects. Of course, the interaction is quantum mediated, but it's just chemist. So, and the cell behaviors. So in this model, the neuron and the glia cells and other physiological units are not quantum objects in this many-body model. The quantum variables is made by the electric dipole of water molecule. You see? Okay. Now,
sorry, Giuseppe.
It's 1 hour.
Yeah, you told me to warn you when it was an hour, but please do finish what you're saying.
Okay, I will stop because here now there came the time, which was interesting for in the discussion of yesterday too, and it came also here, and maybe then we'll try to give. Okay, now. If you have to study a system which is an open system, energy is flowing out of the system, you must ask to yourself where it's going. So you have to study both the system and its environment. If you study, you cannot do, the mathematics. In the title of my book, My Double Unveiled, unveiled means that I did not know that there was a double. It was the mathematics that was unveiling to me that there was a double. Because if you study an open system, you need not only the system, but you need also the environment in order to consider both of them together, and then you have a closed system. This is why it is so, because the mathematics we have, all the dynamics, all the mechanics, all the physics we have, the canonical theory, we call it canonical in our imperialistic wish to control everything, the canonical theory is only for closed systems. Open systems are non-Hamiltonian systems. We do not know how to treat them. So in order to treat them, we have to consider the environment, to collect them, and to consider if our system is described by some variable, say A sub k, time is short, but you can think of any variable you like, then you have to double. You have your system and this tilde system, which represents the environment. Now, what is the idea? The idea is that the energy of the system minus the energy of the environment is 0. So energy is conserved. So this is a closed system. You apply canonical theory, canonical quantum field theory, canonical whatever you want, mathematics, and then you can work out the formula. You can write integrals, converging integrals. This is unveiling. If I have the brain, I cannot consider the brain without its environment. And what is the environment of the brain? What is my the environment for my brain at this moment? Is the screen of this monitor with your electromagnetic image? I see Shantaine, I see Gary, James, and if I move up and down, I see all of you. So you are my environment at this moment, but you are my environment seen by me. So you are my way to see the environment. You are my world. Each one of you has its own way to see its own world, which we share. It's the same objectively, but from our different point of view, each one of us has its own world. If we go to see an exhibition of photographs, of pictures, and we at the end get out of a gallery, what we have seen? Well, we have seen those pictures. Also, we have seen the photographer, because those pictures are the standpoint of the photographer. So in this model, I describe the environment as a copy, as the double of the system. So A tilde is a doubled set of variables which enter in my mathematics with the proper mathematical scheme, which I have no time, of course, to tell you. And these are the doubled modes. So now I have A and AK. And if I do that, I can construct those sets of bubbling, of orchestra, of neurons, I can consider what happens of the dipole, electric dipole of water molecule correlations. And I can do all these machineries, and I end up with the model, which was published already since a long time ago, but resting on a more general paper on dissipation in quantum field theory, which was a paper with Enrico Celleghini and Mario Rasetti in this year in 1992. So these modes are actually mirror modes. Mirror in which sense? You see, the energy flowing out of me is going in the environment. So if I want to describe the environment, what is in for me is out for the environment. So this mirror is reverting the time arrow. What is forward in time for me, mathematically, is exiting from the environment, coming to me. You see, in this relation, E system minus E environment, this minus is crucial. Energy is time derivative, we know, because you have energy in the exponent E to I, Et. So this time derivative, to get a minus, you must change the sign of time. In such a case, you get such a balance. So in order to balance the flux of energy of everything our brain exchange with the environment, with its environment, these mirror modes are modes in the mirror of time. And now you see, time is broken. Time translational invariance is broken, because now we cannot anymore have continuous translational invariance, as in fact it is, because the brain, we said, is a dissipative system. We have dissipation. We cannot have a Noether theorem. We do not have a fixed time origin. We do not have an origin of time which we can move freely. Now we have a fixed origin of time. So now the now is well defined, not before. Because in the Noether theorem, you might decide that now is 10 o'clock in the morning, but I changed the origin and it becomes 11 o'clock. So there is no now. But once you have on your drive license your birth date, you cannot change that. If you change on your drive license your birth date and the CAP stops you, he will jail you. because you are not allowed to change that birth date. So now exists. And this is the root of our thinking. The brain, in this sense, becomes a macroscopic quantum state. The brain state, which goes through, because I say this because the root, we cannot miss the quantum root of what I'm saying. And what appears is the coherence of the correlations, that the phonon, they do not interact. They are coherently sitting in the crystal without negative interference. In physics, we say that by using the word coherence. And coherent states, the laser state, for example, is one beautiful example, but a magnet is the same, a coherent states of magnons, a crystal of phonons, an hadron of quarks, and so on. And we have a change of scale, because we go from the microscopic single units of the story to a collective mode, to the system size. And so we have a change of scale from microscopic to macroscopic. At the root of all of it, there is the openness of the brain, dissipation. Then you have a time evolution state at finite volume V, controlled by entropy variation. Here I'm summing up, you need many steps to say something, but just to communicate to you the result. And thus you have irreversibility of time evolution, which means a breakdown also of time reversal symmetry, and the arrow of time appears, namely a privileged direction in time evolution, which we feel, and which is felt even at the cosmological level and the thermodynamical level. This is George Sudarshan, another great friend and master of mine, and who has been studying dissipation, dissipative system for a life, and the arrow of time. He has been at Austin in Texas for most of his life. So at the end of the story of memory is not a representation of the stimulus, because we have a different stimulus, they can trigger the same memory. So you can, here now I just will rush a little bit. Maybe if you have questions, I will come again. Now, there is one crucial point. Memory is never memory of data. Brain does not care about data. Brain cares about meanings. The functional activity of a brain is the creation of a meaning. So memory, memory recording is always formation of a meaning. Meanings. And what we remember are meanings, not data. If we remember a data, it is because there is a meaning associated with that data. This is completely different from any machinery. In fact, von Neumann was stressing this point in his book by saying that for the brain makes in very few short steps what a computing machine makes in many long coordinated steps. But maybe it's better if I stop here, because there are other things which can come out. Okay, I stop here because discussion I think is important. There are many you can derive. Oh, this is the quotation by von Neumann, John von Neumann. I mean, von Neumann, he knew what he was talking about. And mathematical or logical language truly used by the central nervous system is characterized by less logical and arithmetic depth than what we normally use to. We require exquisite numerical precision over many logical steps to achieve what the brains accomplish in very few short steps. This is, yesterday came this point into discussion. You see, we are still under the illuministic illusion of reason as rationality. We should listen a little bit more to Spinoza about the intuitive science. We have a level of comprehension which is non-computational, as Roger Penrose would say. This non-computational activity is the act of consciousness, which cannot even be forced within a linguistic cage, because language is by its nature a computational instrument. So this brings to me, I apologize for, okay, I used to say that errare is pensare. Pensare is to think. Errare in Italian is a beautiful word because it means to make mistakes, and to make mistakes is helpful in thinking, but it means also wandering around. And a true pensare, true thinking activity is related with wandering and making mistakes. There is nothing of a logical necessity. That comes afterward. The mathematical activity, Roger Penrose says, is doing postulates, not proving theorems. A machine can prove a theorem. Everything is in the hypothesis. You just need to put a chain of a logical step. But making a postulate, there you need creativity. You need intuition. You need to see at a glance what will be a full book of theorems. But I stop here, otherwise, James, sorry. Okay.
No, don't apologize. That was a fantastic presentation. I mean, just not only from me, I've received many praise for you about the clarity and the simplicity that you've presented these topics, which is amazing. So thank you very much for your presentation. Before we go to Shantena, I actually have a bit of a question for you. So to me, I think one of the most radical ideas you've put forward, which I love, is the fact that when studying the brain, we shouldn't study the brain as in brain in a vat. You should say, think about it, brain in the environment, which is very interesting in itself. But of course, every one of us have a different environment. Not only, you know, we may be sitting all in the same room, but it's a different environment for everyone else. And also what you've said about memory storage. Together with that, my question to you is, what does that say about objectivity? Because if we all have different environments, we must have different, we store memories differently, but also how the world to us will appear differently.
Yeah. Yes, thank you very much for this answer. You see, when I have such a question, I used to say that the world was the same before the disappearance of dinosaurs and after. The dinosaurs were not necessary to the existence of the world. The same is for us. I do not dare to define what is objective or not objective, because sincerely, this question, okay, let's make such kind of a game. Let's take two philosophers, mathematicians, whatever you want, any sort of people, literally, and ask them to discuss about objectivity, but objectivity of their checking account. When you talk of money, everything becomes subjective. Any solipsism disappears. And while those guys are discussing about objectivity, the bankers are stealing their money. Now, what I mean is that there are things which we need to believe they are objective. And we need not only to believe, but also to use as they would be objective. Of course, there is credit cards, that is virtual money. But virtual means that if I use my card, I get a piece of bread. A piece of bread is objective. So I do not want to enter in more details of that. But one crucial point is that you, James, you have your double. And your double is one of your life, of your exchange every day. I mean, there is a dialogue. I can give to you at the end a beautiful piece by Borges about double. Beautiful, really. But in any case. So I have a mine. So we are, you and me, we are four. Because not only I have to create a sort of a syntony with my double, but you with yours, but all together. And this is complicated. So what appears, what we experiment, is that we have a social brain. We have a culture, a cultural atmosphere within which we recognize each other and is helpful to share my double with yours and vice versa. Because we have, I mean, we have a common code on which we agree. Now, I do not want to stretch the point. Already this is crucial. Think of arts. Every painting, take a Kandinsky or whatever you like, is different for me and for you, but it is something on which we agree, which we like both. Now, take for example, somebody making a boat. Maestro d'ascia, a master of, you know, usual making a boat out of wood. You need some kind of artisan, master. Archimedes law was not known yet, but even if known, the master does not care. So he makes a boat. Then you put this boat in the sea or into water in any case, and the boat is not good. It sinks. So what we say is not convenient to use it. You see, science in its real substance is convenience. We agree that the second principle of thermodynamics is true. Because if we agree, then our car can move. Is a sort of objectiveness at work. But why nature should be respectful of our mathematics and not of the mathematics of some alien in some lost planet somewhere in the universe? The same nature. So even in science, there is at some point a convenience. We agree that something is true, which is one of the Gödel theorem. We cannot close the circle. We need something outside. And we might accept or change our mind and accept something else at some moment. So thank you for your question, but okay.
that was fantastic, beautifully answered. Thank you very much. Yes, so can I just ask you, could you stop screen sharing so we can see everyone?
Oh yeah, sure, of course. This is what I would.
Thank you. Yes, just before we open to Q&A, I don't know if Shantena, the chair of this event, you'd like to ask something to Giuseppe?
Sure, yeah, absolutely. First of all, to thank you, Giuseppe, for a fantastic presentation, very rich. I will need to study a long time. And let me just ask you a question, but try not to take too much time because I'm sure many people want to ask you a question. I'm very interested in determinism and indeterminism in the brain activity. So you've mentioned like phase transition, breaking of symmetry. To what extent those are uniquely correlated with the environment, with the double, and in which extent there's an element of the unpredictable that emerges there.
Thank you. You see, one of the main results, there is a beautiful Scientific American of 1999, something, no, 79. Okay, I have the reference, but by Walter Freeman. He discovered the role of chaos in the brain. And this chaos is a deterministic chaos, which looks like an oxymoron, but it means that the system is such that the dynamics of the system, the one I was talking of, the dynamics allows is one of a non-linear dynamical system. So it is possible that your equations, if you change just tiny change in your boundary conditions, you get diverging trajectories, and these trajectories are chaotic because they diverge, they never cross themselves, and they are well defined, and they are deterministic. Once you are on one of that trajectory, everything is determined step by step. Every step depends on the step preceding step. However, that trajectory is chaotic. So you see, this is a beautiful play between which one is the trajectory on which you are now, which is deterministic because you wanted to ask the question to me, and you did. And you formulated in a language which is, as we were saying before, a cage, a logical cage. You must use the grammatics, the syntax, otherwise we will not understand each other. So that all of it is deterministic. But when it came to your mind to ask such a question, I do not want to know that, but my point is how the brain came up with such a question, your brain in this case, came up with such a question, because he was wondering, errare, he was wondering among many possibilities, among many, and then one trajectory was taken. And this is very efficient, extremely efficient. It's not to find chaos in everyday language, chaos, I do not know what to do, in the, as contraposed to not determined, no? Chaotic as something. No. Walter was always telling me about an experiment on a rabbit. If you put a rabbit in a room, clean of any olfactory noise, and you put a carrot somewhere in the room, the rabbit will find that carrot in very long time, because he will span almost all room. If you put some olfactory noise in the room, the rabbit will find the carrot immediately, because as physicists we say the derivative is what is important, because by difference he was moving through diverging trajectories. So the role of chaos is crucial as efficient. We actually now, we do not know how to construct a chaotic machine. Because we still do not manage machinery, I mean engineering in such a way, but brain does. Errare e pensare.
That's why we think better when we're walking.
Perhaps, yes, peripatetici, of course. Of course, many things came to your mind, and they overlap, and you discover. You see, the dimension of the brain, this was in one of the slides, is astonishment. Astonishment is surprise, is when something comes which was not necessarily predicted, was not one ring in a chain of necessary steps. And we know that the boredom, la noia, the boredom, is the end. I mean, is depression, is there is a bunch of literature about that.
Thank you, Giuseppe. Wonderful being with you.
Amazing. Right. Thank you, Shantina, for that back and forth. Yes, now we can open it up to everyone. As I said earlier, to ask your question, use the raise your hand function that can be found in reactions at the bottom of your screen. If you're feeling shy, you can write your question in the chat. I can read it out for you, or you can use the raise your hand. Well, actually raise your hand, and if I spot you, I'll call you out. The first question will come from John, who's had his hand up for a long time now.
Thanks, James, and thanks, Giuseppe. That was a really fascinating talk, and I'm going to have to go back and listen to it again, of course. So my question is about the implications of this model for some of our more subjective experiences, and I'm thinking mostly of the concept of self, but also trauma particularly, because I find it really fascinating to think about you know, trauma as being some kind of energy disruption to the field, like to this dynamic system. So I just wanted to know if you had any thoughts on, or what thoughts you had on that, and thanks again.
If I understood well, you are interested in the dramatic aspect, in the interruption, let's say, of the relation between the self and its double, in some sense.
Yeah. And also how that impacts, you know, like the traumas that we experience, like kind of how the physics level would relate to our more subjective sense of, you know,
yes,
experiencing trauma, since trauma is a specific type of memory.
Yes, you see, I use the word double taken from literature, because there is a lot of double in the literature, of course, and not socia. Oh, I might show to you two pictures. One is Narciso by Caravaggio. And Narcissus, I mean, he loves himself. There is a closed loop with his double. The double becomes himself. There is no room for other ones. This is Narciso. And this is dramatic. You have you get in depression and you get lost. And while we talk, I will try to find this picture of Narcissus. And then there is another painting which is beautiful, and is Venere allo specchio, the mirroring Venus, but there are many of them. The one I mean is by Velázquez. That one is in London at how is called the main
National Gallery.
The big gallery, the big museum in London. Okay, and that one is beautiful because Venus is watching through a mirror held by Cupido, is watching at her. Namely, the mirror. In the mirror, you can see the face of Venus, which means the Venus is not mirroring herself, but is mirroring someone who is watching her. And that is openness. Let me see if I can get this. Then one more thing I could tell you. I could choose this occasion of your question, thank you, to show you the slides about Borges, where this is a short page. I should share the screen again. What is this one? These are fractals because the brain is fractal acting. Okay, you see, this is taken by from Borges and I in El Hacedor. There are many editions. I took from a book this edition. Okay, Borges, right, but please, at the end of the story, you see. The other one, the one called Borges is one thing happen to. It will be an exaggeration to say that ours is a hostile relationship. I live, let myself go on living, so that Borges may contrive his literature. And this literature justifies me. Besides, I am destined to perish, definitively, and only some instant of myself can survive him. Spinoza knew that all things long to persist in their being. The stone eternally wants to be stone and tiger a tiger. I shall remain in Borges, not in myself, if it is true that I am someone. He's talking about my double. Years ago, I tried to free myself from him and went from my mythologies of the suburbs to the games with time and infinity. But those games belong to Borges now, and I shall have to imagine other things. So it's a complicated dialogue with your double, John. Thus, my life is a flight, and I lose everything, and everything belongs to oblivion, or to him. Now, Borges, he was great, of course, taking a joke of everybody. I do not know which of us has written this page, which is the point. The point you were asking is exactly the one of, I mean, it happens something very bad if you close somebody, if you detach him from his double. There are experiments with Volunders, or also because there are bad peoples, but the person closed in a room without any kind of distinction in a almost symmetric situation, let's say. He lost the cognition of time, he lost consciousness, he may kill himself. It's not the case when somebody is in a prison and behaves in a bad way. He is put in isolation. Isolation is just like a torture, because there is no, his double is reduced a lot, completely. You see, so there is a big problem. But there is also, just to open the way, not only to drama, there is also a moment in which we almost identify with our double, and that is the moment in which we dream. I have a recent paper with Tanya Ray on dream, where we talk about these things, but I do not want to enter in this point, otherwise, please, another question, otherwise, I mean, too long. Okay.
Great, thank you, John, for your question. The next question will come from Claudia.
Hi to all. It is possible to make the question in Italian, please, because I understand everything, but for me it's very difficult to speak with the property of language.
Sure.
I can be very short in my question, but for me is maybe someone can translate.
I'll try and translate for you. Don't worry.
James can do it.
Scusate. Io non studio fisica, io mi occupo di sistemi di pensiero gnostici protocristiani, e la faccenda del doppio è molto attuale in quei sistemi di pensiero. Quindi chiedo, io faccio fatica a pensare che tu fino adesso hai parlato, mi sembra, di necessità di correlazioni di sistemi a livello, diciamo così, orizzontale, ok? Della stessa scala, perché se io mi correlo con te, con James, siamo sulla stessa scala, potrei dire anche sulla stessa dimensione. La comunità, il mezzo, analogicamente parlando l'acqua, fra di noi, io faccio fatica a pensarla alla stessa scala. Ci serve anche una correlazione verticale. Cioè, una dimensione che corrisponda al mare, mentre noi che siamo dei pattern, diciamo delle correlazioni a lungo termine, cioè con un certo range di stabilità, possiamo essere come delle onde, cioè un qualcosa che emerge e poi si riimmerge. E in questo modo mi viene anche più semplice pensare che la nostra memoria attinge a una dimensione sottostante, a una substance, come giustamente questo termine, e a una dimensione sottostante dove non è immagazzinata come un file, ma si crea nel momento in cui noi ci dirigiamo verso in una certa direzione. Nel momento in cui ci voltiamo in un'altra direzione, questa sparisce, perché non ha un'esistenza autonoma, come dici tu, perché in un ordine implicato non ci sono degli oggetti, c'è un mezzo che permette delle correlazioni che si manifestano però a una diversa scala, che può essere la nostra. Come dire, mi viene da pensare che ci sia di necessità debba esistere una dimensione che magari Bohm poteva chiamare ordine implicato, ok? Che è da cui noi in realtà non ci stacchiamo mai. Esistiamo anche in quell'ordine, ma non lo percepiamo a livello cosciente. Cioè, mentre ad esempio in questi sistemi antichi, chiaramente con diversi termini, si cercava di restituire attraverso anche solo un'idea di Dio di una pienezza dinamizzata, perché usavano questi termini qua, di una impersonale pienezza dinamizzata, si cercava di raggiungere la coscienza, la percezione cosciente di questo tipo di dimensione, nella quale noi siamo immersi e in un certo modo emergiamo. Emergiamo per un tempo, fra virgolette, perché la questione del tempo poi è la direzionalità del tempo. Se noi supponiamo questa dimensione sottostante, si annulla, siamo lì, noi viviamo contemporaneamente in un eterno presente.
Scusi.
E anche in una macro dimensione che apparentemente implica una direzionalità del tempo. Chiudo.
Sorry, Claudia, it was a bit long. I couldn't really translate. So did you have, what was the question then for me to translate?
No, direi, io sono un po', ok, il discorso sarebbe lungo, ma basta così.
So
allora,
could you please answer in English, just because not everyone
speaks
English.
Okay. The argument is would be very long, so
yeah, I mean, if
Giuseppe
could just answer in English.
Allora, Claudia, Claudia, rispondo in inglese, va bene per te?
Sì, perfect.
Ecco. So maybe by answering in English, if I understood well the question or the comment in general, it can be useful also to understand which one was the comment and the question.
Okay.
Sorry. Okay. Claudia, you were indeed talking of the community of the brains. Let me use this expression. This community includes, of course, humans, but includes also other brains, and includes the world. And this was already, in some sense, related to the question or comment by James at the beginning, if I'm not wrong.
Yes, absolutely.
Yeah. Now, already at that point, there was the problem of a check, of closing the ring. Where are we? We are fish in the. You were talking of the sea and waves on the sea, but even more, we are fish in the sea, and we would like to know what there is outside the sea, which was more or less the questions of the double of Borges. a tiger wants to be a tiger, but who I am, he was asking. You see, this is the point where we need culture. And the culture, by culture, I mean an atmosphere of this community of brains in which we live. Mm-hmm. And this atmosphere is not limited by some external constraint. Mm-hmm. In that case, it's no more an atmosphere. I mean, it's like a region of that sea. I mean, not. When I say culture, it includes arts, it includes religion, it includes love, it includes, unfortunately, war. It includes whatever is our life experience. So in this sense, we have one more dimension, which is a dimension through which we can change not only the self, but also our double. And together work with other self and doubles and respective doubles in the construction of a different culture. Mm-hmm. But this is the only possibility that we have is a collective mode. Mm-hmm. This is why is so stupid. The word stupid maybe is too light. In English is very strong, but even in English is too light. It's very stupid to keep people away, people running from war, just because we do not want our neighbor speaking English if we are Italian or having a skin of a different color from us. This is stupidity, because we are on the same boat. By the way, I do not have in these slides, but here I would like to remember Sabin, who did not patented his vaccine against poliomielite because he wanted to be free for everybody. And the answer was that he did not get the Nobel Prize because of that. Mm-hmm. And this is, I mean, it's a shame for the Nobel Prize Committee and the glory for Sabin. And it's a shame for today stupidity of not sharing vaccine to those who believing to be more secure with vaccine as we need for everybody. But not because they could come here and bring again, just to say, so for interest, just for humanity. So this is the other dimension, the social brain. Mm-hmm. And this social brain is intrinsic in the brain activity. Mm-hmm. Because our body, I need air. And the same air is the same that you perspire. So we cannot cut. This is my air. This is, I mean, we have a body. Our body is extremely important. Mm-hmm. There was one of the conference on consciousness organized by the group of Amerov. It was held in Tokyo. I do not remember the year, but in any case, the proceeding was no matter, never mind, putting together two ways of saying no matter, never mind. Just forget about other levels. But what we know, what we see, is the brain is made in such a way that we cannot separate among ourselves. We are just one big body.
Thank you, Claudia, for your question. We should move on. I know we've got 3 hands up, so hopefully we'll be able to make through them all. But the next question should come from Luis.
Thank you, James. And congratulations, Professor Giuseppe. I am based in Miami. I am the president of the World Happiness Foundation. And now we are working with the families of the drama, the building collapse. You remember a few weeks ago. So it's very interesting because the way we use our therapy, we believe in collective healing for collective drama. But I wanted to ask you, because it's very difficult, especially in an environment like the US, where everybody is so individualistic, to do collective healing. So I was going to ask you, if we think of the individual, we think of the community, and we think of the collective, is there one of those three levels that has a major impact on the whole system to start with, or they are all interconnected and there is always feedback loops in between among all of them? So yes, it's a question that relates psychology, neuroscience, and quantum, but I feel this is a really practical case, it's a real case, and we are right now on the ground. So if you can give us some insight, that would be fantastic. Thank you.
Yeah, this is thank you, thank you. I'm looking for the slides where this point was taken. Okay, let me share the screen. You can see these slides with Glauber. Glauber, yeah, I mean, he was the theorist, and at the end he also worked practically to realize the laser beam. Now, all of it from a physical point of view is based on the concept of coherence. Coherence means not negative interference. So it's not the exclusion of the individual, but is the cooperation of a main individual to create a collective system. What is a laser? One example is, for example, when you have a tornado, when you have a hurricane, you have water molecules. Each one is just nothing. But if they are in a collective mode, they can be very dangerous, like an hurricane. Now, in the coherence, you have, you see this statement, a system is a quantum coherent if its parts are so perfectly correlated that their cross correlation are exactly the product of the individual self-correlations, so that each appears paradoxically totally uncorrelated with the rest. It is a state of maximum local and global cohesion. So the true individualism, I take this out, the true individualism cannot miss the collective level. You see, let me say in this way, we have from a financial and commercial point of view, globalization, which was a request of a market. We need the larger market. I mean, so the motivation is very technical, and if you want, you might like it or not. I mean, but we have a global, but globalization is also necessary because the Earth is just one planet. It's the only one which is where life exists as we know up to now. So globalization is by itself there. This is why you are Luis Gallardo and I'm Giuseppe Vitiello, and there is Guru Sharan and Gary Goldberg and all that. We are just one single person. In each, in our dialogue with our own double, we talk with everybody of you. Oh, I mean, you understand what I mean. But this is you see, this is a little bit paradoxical. But Glauber, he understood that in the coherence does not destroy the individual. Without atoms, the single atom, you cannot make a crystal, but a crystal is something else than just a single atom. You need both. They are different dynamical levels. So the theoretical structure of a quantum field theory, I'm not insisting now on quantum, but is interesting because it brings together the possibility to have many stories, many novels, and to have phase transitions. We can go from Louis to Giuseppe to Gary and so on, and vice versa. I do not insist, but we might talk.
Great, thank you, Luis. Giuseppe, we only have about 2 minutes left. Would you be happy to take maybe one more question quickly?
Sure.
Okay, great. We'll take it from Gary then.
Okay. First of all, thank you so much for this talk. It was really stimulating and beautiful. And I totally agree with the idea that we are all part of one organism and that the fundamental reality of the universe is consciousness. And so if we are all individual, we need to have some way, that is, if we are all part of one thing, but we are individuals simultaneously, we need to be in communication with each other, right? So ultimately, my argument is that consciousness is for the purpose of agency, which is for the purpose of communication. And so one of the things about the brain is that it has 3 major elements in the cerebrum: a left hemisphere, a right hemisphere, and a corpus callosum that connects the two. And the question is, why is the brain structured like this? And you know, that I don't know how many people are familiar with the Dirac diagram, but from Paul Dirac, that basically lines up on one side energy, and on the other side entropy, and makes this distinction between the two. And so now the interesting argument is that, well, then we have one hemisphere for one and one hemisphere for the other. And what's really interesting about that is recent research that has been done on the way that we listen to and decode music that has lyrics associated with it. And this is the work from Latour's lab at Montreal Neurological Hospital, where they very clearly show, right, that melody is decoded in the right hemisphere and lyrics are decoded in the left hemisphere. Very clearly, distinct, okay? And the way that they do this is they break down lyrics by taking out pieces of time, samples in time, okay? And as you degrade in time, you begin to lose the ability to make out the lyrics because the phonemes become indistinct. The sequence of phonemes become indistinct. And now you can't hear. Like, what did that say? What did they say? I mean, and then they show that if you take out elements in the frequency domain, you lose the melody. Now the melody becomes indistinct. You can see, you can hear the lyrics, but the melody goes away, right? And so the question becomes, like, do we have one side of our brain that is specialized in dealing with frequency and therefore with a continuity of time, whereas the other side is dealing with time as a sampled element in frames, right? In separate frames, segmented frames. And that we kind of have to balance between this connection with a temporal continuum and a breaking up of that temporal continuum. You see what I'm saying? Like,
yeah.
And the Dirac diagram completely, corresponds to that.
Yeah, yeah.
Right, because it basically has frequency on one side and time on the other side.
Yeah, you see, one point I can read this fact, because you are mentioning some observational fact, is that once more, I apologize because I am a theorist, so my focus immediately goes on the structures. So once more, we deal with a double system, a system made of two parts, which they might balance or unbalance. And in your case, the question was about left and right hemisphere. Now, this left and right is exactly what we do in our perceptual experience every day. You see, I mean, how to say mancino, left-handed. But at the elementary school, when I was a boy, that was not respectable to be left-handed. So they taught me to write with right hand, and which is too bad. So I have always problems with left and right. And yes, you are just showing. And I always try to balance both of them. Which comes a little bit stressing or tiring, but that's fine, is the game. I don't know, but in any case, it's quite interesting what you are saying from the point of view of melody and poetry, because both they live on the vagueness. The word is well defined in mathematics. You cannot have ambiguous meaning in a word, and also in everyday language. But if every word would be perfectly defined in its meaning, that is not good for poetry. Poetry comes from the vagueness of the word. And melody, on the contrary, in some sense, contrary, but not so much, comes from the matching of two frequencies, or if you want, the ratio between. But that is at the end of the story the same mechanism. Only one is applied to the linguistic aspect, the other one on the auditory aspect. And this is a very, very interesting problem. Yeah. If I have just 1 second, this is the picture. Let me share the screen of Narciso and Venere. I was telling you. You see? Can you see this? Can you see it? Is
yeah, we can hear. We can see.
You can see. This is Narcissus by Caravaggio. Is 1597. Is oil and so on. This is in Rome. You see this closed circle of the arms. This is Caravaggio is beautiful. And il fondo, come si dice? The background is black, just black. John was the one putting the question about the problems in. So this is the socia. This is a discussion of Narcissus with this socia. There is nobody except Narcissus here in the mirror. This one instead is the painting by Velázquez. You see, this is Venus. This is at the National Gallery in London. Sorry, you are about at the same time, because this is 1647. Well, this is 50 years after, let's say. This is Venus, but this is Cupido with mirror. But you see, from the law of optics, if Venus was mirroring herself, we would not see her face in the mirror. So Venus is watching at her observer. Which are you watching at the painting? You see, through the mirror, you see the face of Venus, and Venus see your face. I mean, the law of optics, of geometric optics, means that at the radius, the impinging radius makes the same angle with the normal, with the diverging one. So just experiment yourself. Take a mirror and see what happens if you want to see the face of someone in your back. You are not watching at your face. This is the open system. This is the closed system. The open system is this one. This is Claudia, the other dimension.
Leroy Little Bear.
Excuse me?
Sorry,
okay.
Bit of interference.
Okay, yeah. So this is the dimension, one more dimension the brain has, is openness. Openness means dissipation. Dissipation means exchange of energy. Is, if you want, generosity. Not just giving, but also receiving, accepting the other one, and so on. But these two paintings are striking to me in this description. They could be in a mathematics book.
Great, thank you, Gary, for your question. Now we have gone a little over, so I guess we should close the session. Giuseppe, do you have any quick yeah, sorry, Guruchan, we did want to ask, but it's getting a bit late, sorry. Giuseppe, do you have any final, quick final remarks to give us before we close?
There is a remark about another finding. You see, you must be lucky in your life. I mean, to meet the right people. I was very like meeting Walter Freeman, among others, of course. And he also has been the first, or one of the first, of the very first, in showing that brain activity has a self-similarity property. Namely, there is a fractal dimension in some evoked signal taken from the brain under some stimulus. There are papers on that. Now, this fact is very interesting, because even in the brain, which is so how do you say, sacro, so holy, is an holy, but is a natural system, there is a fractal, and nature loves fractals. Now, there is a theorem which you can show, you can prove, where you show that if you have a fractal, then you must have a coherent state. So fractal and coherence, they came together. So that observation in the neuroscience lab, from one side is a confirmation of the coherence in the correlations we were talking about. But it is also, how to say, opening the door to a quite more global understanding, unifying our understanding of nature. We have perhaps one single law at the basis, and that is the law of coherence. Coherence means formation of forms, means unfolding of order, just to use these words. But let me give you perhaps a sentence, a famous one, by Darwin, which we might use to say hello each other, which is this one. In this view of life, with these several powers, having been originally breathed into a few forms of into one, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved. I think this is David Bohm. can be signed also, because you see here you have something which is into one or few form. I mean, something which is implied and then develops. You see, this is so I found this sentence quite near to what we are discussing in this meeting, and also dynamical rearrangement of symmetry, or if you want, we started with. Okay.
Okay, great. Thank you so much, Giuseppe, for your presentation, for your great answers during Q&A. And thank you all for joining us. Before we go, I'd just like to very quickly invite you to next week's session for our second week of Beyond Bohm series. On Saturday, we'll have Basil Hiley, who will talk about the Dirac-Bohm picture, Bohm's 1952 approach in a wider context. And on Sunday, we will have Pavel Pilkanen on understanding the nature of reality and consciousness, Bohm's philosophical project. To contact us, you can use us the website in the contact us section, or you can write to us on Facebook, Twitter, Instagram, all over the place, including email. You can email me personally at james@powercenter.com, or eleanor@powercenter.com to contact Eleanor. Thank you again for joining us, and we'll see you again soon here at the Power Center. Bye-bye.
Bye.